does a blockchain work? New transactions are broadcast to all nodes. Each node collects new transactions into a block. Each node works on finding a solution to a difficult-to-solve cryptographic puzzle. When a node finds a solution to this cryptographic puzzle, then it broadcasts the new block to all nodes on the blockchain network. The other nodes verify the solution provided and accept the block to validate it. Nodes express their acceptance of the block by working on creating the next block in the chain using the hash of the accepted block as the previous hash. Blockchain needs a few elements to function. It requires a peer-to-peer network, which is nothing but a network of computers connected to each other. Each of these computers is called a node. Each computer or node has the same rights and responsibilities. Any computer can become a node, emphasizing the decentralization. This connection also allows for sharing of information remotely. Cryptography secures the blockchain, thereby allowing a participant to verify transactions and messages. A consensus algorithm? Yes, a very big term sounding very technical. But this is nothing but all nodes or computers agreeing to rule on adding a block to the blockchain. Some of the most common consensus algorithm rules are proof of work and proof of stake, which we shall discuss in greater detail subsequently. All nodes follow a set of rules to reach a consensus. All nodes that add new blocks and maintain the records are given rewards for their contribution to the blockchain. This reward is in the form of a cryptocurrency. So let's dive deep into nodes and their functionality. Nodes are computers connected to the peer-to-peer network. They are the points where data is stored and processed and also perform various other functions such as verification, validation, addition of transactions to blocks, and addition of blocks to the blockchain. Now, the next thing we want to talk about is proof of work and its very best alternative, proof of stake, and whole idea of blockchain consensus mechanism. Proof of work involves a huge consumption of energy by highly specialized processors called ASIC chips that do the number crunching for solving the cryptographic puzzle by crypto miners who operate the nodes. This leaves a large carbon footprint due to the power consumption. On the other hand, proof of stake is gradually gaining acceptance. This mechanism allocates block to miners based on the proportion of the number of cryptocurrencies held instead of raw computation power like proof of work. This is expected to ease the demand for electricity. There are various other types of consensus mechanism such as proof of activity, delegated proof of stake, proof of capacity, proof of elapsed time, proof of identity, and proof of authority as illustrated in the table. Now to turn for a quick brief on the various layers of blockchain. Blockchain are built on layers. Layer 1 is the foundation on which the project is developed. This is the mainnet, the grounding. It has all the essential characteristics of a blockchain network. It is distributed, immutable, decentralized, public, and scalable. The Bitcoin blockchain follows the proof of work consensus algorithm. This is a system in which miners operate and decrypt mathematical problems to mine a block as well as validate and verify transactions. Another concept that has emerged is the proof of stake, which is less resource or energy intensive. Here, nodes or computers validate transactions based on their stake in the network. To build on the blockchain network came the Layer 2, which sits on top of Layer 1 network. This ensures that the blockchain overcomes scaling issues and increases speed of transactions, thus reducing cost. Although the speed of transactions on Ethereum is faster than that of Bitcoin blockchain, it is far slower than numerous others. Both these blockchain networks are working on the Layer 2 developments. Lightning Network for Bitcoin and Layer 2 network for Ethereum. On the Ethereum network, dApps will get a major boost on Layer 2 network. Let us discuss a couple of real-life examples of blockchain's concept of decentralization and distribution. Let us take an example of a group of 10 women who meet for a kitty party each month. Assume that they pool together 1,000 rupees. A lucky draw is conducted in which one member wins the total sum of 1,000 rupees each month. The caveat being the winner of each month's kitty party is ineligible to become the winner in the subsequent month's kitty party. But all members are still required to attend the forthcoming month's kitty parties and contribute to the corpus. In such a social group, trust among members is of paramount importance. There is no central authority to enforce the rules of kitty parties. It is simply based on trust reposed by all the women in the social group. Let us take another example of a teacher grading the exam of students, because all students' grades are awarded by a single teacher. This is similar to a centralized authority who issues grades. Now let us assume that all students obtain the right to view the grades of the other students. Then this would involve a consensus among all students on the grades awarded to the specific student. But what is the incentive for other students to award grades? The other students would be paid a transaction fees for awarding the grade. Next, let's introduce the fact the blockchain is immutable. To do so, let's dive into the pieces that make up a blockchain. The validated block that is included in the blockchain cannot be removed easily due to the password that interconnects all the blocks, as we had discussed earlier, thereby ensuring data integrity. This password is also referred to as a hash. The connection between the blocks is often called a linked list of hash table. The encryption of the entire data is generated using cryptographic algorithms. Each validated block that is added to the blockchain hashes its transaction data along with the hash created in the previous block, thereby generating a new hash altogether. This process is repeated for subsequent blocks that are created to form the blockchain. Now the key question arises as to how all these nodes unanimously agree on the validation and verification of the encrypted database. That is, how is a consensus reached among so many computers? This is possible through a decentralized mechanism whereby only when a majority of nodes have consensus on the validity of specific transaction data that is received, then only would the validated block be included to form a part of the blockchain. Stay tuned for the next session to continue your learning.